Hi everybody, this is going to be a short video over zeros of polynomial functions. So the first way that we can identify zeros of a polynomial function is by graphing. So it's as simple as it was with quadratics. We're looking for the points where our graph is intersecting or hitting the x-axis. So for this example, if you type this into your graphing calculator, you're going to have a graph that looks like this. And we have 3 zeros that we can find. So we would just list them out. Our zeros are at -1, +1, and +3. So it's that easy. We have quite a few more than we did with quadratics. With quadratics, we had 0, 1, or 2. With these higher polynomials, we're going to start getting more zeros here. So graphing is pretty straightforward. Another way is we could factor and find the zeros. So let's say we have this function here. If I wanted to solve by factoring, we need to factor out a GCF first. So we'd factor out x. We're left with x squared minus 2x minus 15. And then from here, we have a quadratic trinomial that we can factor by thinking what two numbers multiply to -15 and add to -2. Okay, well, those two numbers would be -5 and 3. So it factors into x minus 5 times x plus 3. And then from here, we're trying to find the zeros. So our function is equal to 0. We're finding the x values that make this function equal to 0. So we set each factor individually to 0, and we solve for x. So we get x equals 0, x equals 5, and x equals -3. So far, very similar to what we saw with quadratics. Not a big difference. Now, with polynomial functions, we're going to start seeing something called multiplicity. And multiplicity of a 0 is equal to the number of times its corresponding factor occurs in the factored form of that polynomial. So new polynomial here, x cubed minus 6x squared plus 9x. So let's factor this first. Pull out a GCF of x, left with x squared minus 6x plus 9. Well, when I go to factor this part here, the two numbers that multiply to 9 and add to -6 are -3 and -3. So when I factor, I get two of the same factors. I get two factors of x minus 3. So that means if I'm finding my zeros, I get two solutions, or two zeros at 3. So what we say is we have zeros of 0 and 3, but this 0 here of 3 has a multiplicity of 2 because its corresponding factor occurred twice in the factored form. 0, okay, its factor only occurred once here, so it would have a multiplicity, and I'll abbreviate here, a multiplicity of 1. Now, something else that we're going to talk about is if I have a cubic function, I should be able to find 3 zeros. Well, visually, graphically, we're only going to see two places where it crosses the x-axis. But if we account for the multiplicities, they are going to add up to 3. Okay, so let's look at how multiplicity affects the graph of a polynomial function. So I've got the same function here that we just factored. We know the zeros should be at 0 and 3, and that's exactly what we see on this graph. But with the multiplicity, we know that multiplicity of 1, 3 had a multiplicity of 2. The effect here is that for our 0 at 0, it had a multiplicity of 1, an odd multiplicity. And whenever we have a 0 with an odd multiplicity, our graph is going to actually cross through the 0 at that point on the graph. But when we have a 0 with an even multiplicity, instead of crossing, our graph comes, it hits that point, and it just bounces right off. So graphically, this is the effect that multiplicity has. Okay, if you have a multiplicity that's odd, it's going to cross at that 0, If you have a multiplicity that's even, it's going to bounce at that 0. So let's say we have this function here. It's already in factored form. Let's find the zeros, their multiplicities, and the effect that it has on the graph at that point. So let's rewrite this. If I have x plus 7 squared, that means I have two factors of x plus 7. I have a single factor of 2x plus 1, and I have three factors of x minus 4. Okay, well, these two factors are going to give me the same 0 at negative 7, but since there's two of them, that means the multiplicity is 2. And since the multiplicity is even, that means that graphically, it's going to bounce at that 0. I have a single factor of 2x plus 1, so that's a 0 at negative 1/2. Multiplicity is odd. It's going to cross at that spot. And then we have three factors of x minus 4, so that gives us a 0 at 4. Multiplicity is 3, and since it's odd, it's going to cross there. So the last example that I want to show you in this video is how we can actually write a polynomial function that represents a specific graph, and we can do this just using the zeros and their multiplicities. So the idea is this. If I have a 0 at negative 6, multiplicity of 2, that means I have two factors that give me that 0. Well, the factor that would give me a 0 at negative 6 would be x plus 6. Okay, that would be the factor that I would set equal to 0 to find that particular 0. Since the multiplicity is 2, it's this factor squared. Now, I also have a 0 at 2 with a multiplicity of 1, so that means I have a factor of x minus 2, and there's a single one of them, so it's just x minus 2. If I multiply this all back together and write it in standard form, now I have a function that's going to have zeros at negative 6 and 2 with those given multiplicities. So let's write this out. X plus 6 squared means we really have to expand this and write it as x plus 6 times x plus 6, and then x minus 2 at the end. So let's multiply. I'm going to multiply these two together first. So we get x plus 6 times x squared minus 2x plus 6x minus 12. Combine our terms here. So now we have x plus 6 times x squared plus 4x minus 12. So now we have a binomial times a trinomial. We end up with x cubed plus 4x squared minus 12x plus 6x squared plus 24x minus 72. After combining like terms, we get a function that's actually in standard form. So remember, standard form means that we are sorting these terms from greatest exponent to smallest exponent. And here we go. If you took this function and typed it in your calculator, you're going to see that this graph has zeros at negative 6 and positive 2. You're going to see that it bounces at negative 6, crosses at a positive 2. So that's just a quick video over zeros of polynomial functions. I hope it helped. Feel free to ask questions, rewatch, rewind, and have a great day.